type Blynk. Press enter. Click on first link. So click on login. Give your login credentials. Click on login. Then click on templates. Click on new templates. Give the name of the template as LED control and choose the hardware ESP8266 and Wi-Fi connection, and write the description to control bulb and click on done. Next step, click on data stream. Click on new data stream. Since I am using digital pin, D4 pin of NodeMCU, I will make use of digital pin. And here you can give the data stream name as LED. I have already used LED in a previous template. Now I will make LED1. And I want to connect my bulb to, sorry, here instead of LED, I will write it as bulb because I am controlling bulb, BULB, bulb. And I want to connect my bulb to pin number 2, that is D4 pin. So through relay, I am connecting the bulb. So to the relay pin, I am connecting D4 pin of NodeMCU to the in pin of relay pin. So I am choosing pin number 2, that is D4 pin of NodeMCU. And I'm making that pin as output mode and create. The next step is click on web dashboard, and here click on visit switch, drag and drop here, and click on settings. Give the name as bulb only. Choose the data stream bulb because in the previous step I have selected data stream as bulb. So I'll select this, and on means 1, off means 0, and save. So immediately after saving, you have to save one more time. This step is very, very important. Third step, click on save. Next, click on search. Click on new device. Click from template and choose the template. The template name initially I gave LED control. So this I should select and create. So after creating, I'll get this code. The code is generated by the Blynk. Copy this code, click to copy code and go to your Arduino IDE software. The copied code from the Blynk, you paste it in the first 3 lines. In this first 3 lines, you will have the template ID and the name of the template and the author token. So these things I have to paste here. Control V. I pasted. So after that, I have to select the port. COM3 port I have already selected, and the board NodeMCU 1.0 ESP12U model. After that, click on upload. So while uploading, it takes a few seconds of time to upload the program. Before uploading the program, it will compile your program. If any errors are there, it will display it. If any errors are there, you debug it. Otherwise, if no errors, we will get done compiling. So you check here, done compiling, and it started uploading. On the left side, it will show the uploading in terms of percentage. You should wait till it becomes 100%. So once it becomes 100%, I have to go back to the web dashboard. So to check whether the switch I can open it or not. So after you come back from the Arduino IDE software to the web dashboard, you close this. So here the bulb widget is already formed, and you should check the template. Next to the template, it should display as online. Online means your ESP82 NodeMCU ESP8266 is connected to your Wi-Fi network. And in this experiment, you should take care when we log in, give the login credential, Gmail ID and password. The same Gmail ID and password you must use in the mobile dashboard. So with the help of, so here again you come back here and click on LED control, click on web dashboard, and after that you will get a visit here. So here you can change your visit on and off. When I on it, LED bulb will be on. When I off, LED or bulb which is connected to the NodeMCU, it will be turned off. To do this experiment, we need one mobile dashboard and a NodeMCU ESP8266 and one single channel 5 volts relay module and one AC bulb which is connected to bulb holder, and the other end of the wire is connected to 2-pin plug to the AC voltage source. And look at the circuit diagram. The D4 pin of NodeMCU is connected to in pin of relay module, and ground of relay module is connected to ground of NodeMCU. VCC pin of relay module is connected to VCC pin of NodeMCU, and this is a 2-pin plug which is connected to 230 volts AC supply, and this is a bulb and a bulb holder, and the one line, it is directly connected to the bulb, and the other one is split into 2 wires. Now one end from the bulb side goes to the common point, and the other wire end from normally open, it goes to the 2-pin plug. So this is the way of connecting relay module, and I have done one video on this, and the video link is given in the description box. So you can go through that, how to connect the bulb and 2-pin plug to the 5 volts single channel relay module. So after doing the connection, the same whatever I explained, the same connection I have done here. D4 pin, VCC and ground are connected to the relay module. After downloading the program, now the web dashboard is also the mobile dashboard is also ready, and in laptop the web dashboard is also ready. Now from web dashboard I can control the lab bulb. Now from mobile dashboard I'll show you how to turn on the bulb. Just go and click here. So your bulb should turn on. So bulb is on. So why it is taking this much delay? Because my network is very slow. If your network is very fast, in a fraction of a second the bulb will be turned on. Now I'll turn off the bulb. Bulb is turned off. Once again I'll show you. Turn on. Bulb is turned on. Now I'll show you the bulb is on now. From the web dashboard I'll turn off the bulb. Now from the web dashboard I'll turn off the bulb. See, the bulb is turned off. So in this way, from the web dashboard you can control the bulb. At the same time, from mobile dashboard also you can control the bulb. In the first line, hash define Blynk template ID. This line defines a preprocessor macro Blynk template ID and assign the value. Some value here it is written, and this template ID it is used for Blynk IoT project to identify and configure the project settings. So the next one is hash define Blynk template name. So this line defines another preprocessor macro, that is Blynk template name, and assign its value LED control. LED control, and this would be the name or description of your Blynk project template. The next line is hash define Blynk auth token. So this line defines preprocessor macro Blynk auth token and set it to the some value, and this is the authentication token, and it allows your device to connect to the Blynk server, and each Blynk server has a unique authentication token. The next line is hash define Blynk print serial. So this line sets the debugging output to the output to be directed to the serial interface. So when you use Blynk print in your code, it means that Blynk library debugging messages will be sent to the serial port, and which is useful for debugging and monitoring your program's behavior. The next line is hash include ESP8266.h. This line includes ESP8266 Wi-Fi library, which provides functions and definitions for connecting to the Wi-Fi networks using ESP8266 based device. And this library is essential for Wi-Fi communication in your project. The next line is hash include Blynk simple ESP8266.h. So this line includes Blynk simple ESP8266 library, which is an Arduino library for easily integrating ESP8266 based devices with the Blynk IoT platform, and it simplifies the process of connecting your device to the Blynk server. The next line is character auth Blynk auth token. So this line defines character array auth, and it initializes it with the value Blynk auth token macro, and this array is used to store authentication token for your Blynk project. The next line is SSID Shantasim and password, and these two lines defines the character array SSID and pass to store the SSID Wi-Fi network name and password for your Wi-Fi network, and you should replace these values with the credential of your specific Wi-Fi network. Next is LED pin is equal to D4. Here I have used the variable LED pin, but in this experiment you are controlling the bulb, so you can write bulb is equal to D4. Anything you can write. Here I have given the variable name as LED pin, because in the previous video also I have used the same variable to control the LED. The same thing I am keeping here. This line declares the integer variable LED and assigns it's the value D4. This variable is used to store GPIO pin number connected to LED. In this case, it is set to pin D4. Next, wide setup, serial begin 115200. It initializes the serial communication for debugging. Then Blynk begin auth SSID pass. So this initializes Blynk with authentication token and Wi-Fi credential. And next is pin mode LED comma output. So this will set the LED pin as output. Here I am making the bulb LED pin on the relay model. So that pin I am making as output pin. Then after that we have a while loop. So this setup is executed. The lines within the setup, these will be executed only once when the device is set up and it performs the task. So what are the tasks it performs? It initializes the serial communication for debugging at the baud rate of 115200, initializes the Blynk library with authentication token of SSID and password, set the LED pin as output, indicating that it will be used to control the bulb. Okay, so and before executing this program, you should install a library. And which library you should install? Go to the sketch. So here you click on include library, go to the manage library, and here you type Blynk, BLYNK. So Blynk you type. So here you will get on the option Blynk by Volodymyr Shamansky. So this library file you have to install. I have already installed, so it is showing me installed. After installation, you have to upload the program. So finally, there is a while loop. So this loop is continuously executed in a loop after the setup function. It calls a blink.run to run the Blynk event loop, which manages the communication with Blynk server. This is necessary to keep the connection alive and handle incoming commands or updates from the Blynk app. So finally, what I can say, this code setups a connection to the Blynk IoT project, connects to Wi-Fi, and prepares to control bulb connected to the pin D4, and it uses Blynk for communication, and it sets up the necessary library file and configuration for the project. So before uploading program, you should cross-verify whether you have selected proper port and proper board. After confirmation, and you click on upload button, it will upload your program to NodeMCU. So in the description box, I have given many links. And the link for how to connect the relay module, single channel 5 volts relay module with the bulb holder and a 2-pin plug, and the link for your code, this project code, and all the links I have given in the description box. So if you get any doubt how to write the code and all, so you can go through the links given in the description box.